In this example, we're going to add one level of complexity to what we saw in the last examples. Now we're going to add an equation into this and solve for n with n factorial divided by n minus 2 factorial equals 90. The only way to deal with this is to actually write out the factorials with definitions, cancel off what we can, and then go and solve the equation like that. So on top we have n factorial, which would be n times n minus 1 times n minus 2 times n minus 3, and so on, until at the end we would times 2 times 1. On the bottom, we would have n minus 2 times n minus 3 times n minus 4, multiplied, etc., until at the end we multiply times 2 times 1. And that equals 90. Looking to cancel what we can, we have factors of n minus 2, n minus 3, n minus 4. Yes, it is there in that omitted section. Everything else in the omitted section, the 2, the 1. Simplifies this down to n times n minus 1 equals 90. Now we have to go back in our bag of tricks and figure out how to solve this. Well, brackets in equations are never a good thing, so we should work to get rid of those. And in this situation, distributing the n in is actually necessary. We would get out of that n squared minus n equals 90. Now this is turned into a quadratic equation because of the n squared, and to solve a quadratic equation we need to have one side equaling 0, so we'll need to move that 90 to the left, subtract it, n squared minus n minus 90 equals 0. And at this point we're left with a choice. We have a few methods of solving quadratic equations. We looked at those back in Foundations 20. Anybody who took Pre-Calculus 20, you've also seen them there. But we have factoring, if that's possible, completing the square, which is also possible. Quadratic formula is the foolproof method, and we should only go there if we absolutely need to, as it is the longest and most involved. I prefer to look at factoring first. So to factor this, we would need two numbers. They need to both multiply to negative 90 and also add to negative 1. Good news is that's not very difficult to come up with because negative 10 and positive 9 would work. So we could factor this into n minus 10 times n plus 9 equals 0. And once we get to this point, once it's factored, we split off the equation both ways, knowing that either n minus 10 could equal 0 or n plus 9 could equal 0. Solving for n, on the left we get n equals 10. On the right we get n equals negative 9. Now, this does raise a small issue, as based on the situation, we will have to reject one of those answers. Keep in mind, this whole unit is dealing with arranging a set of objects, and n in this case would be how many objects we have to arrange. Well, on the left, n equals 10. 10 objects, we can absolutely arrange those. On the right, negative 9 objects does not make sense in the context of the question. The bare math with no context behind it, it's a perfectly valid answer. But in this case, because we have a situation that we need to take account of, it does not make sense, so we will have to reject that answer.